back to the real number system. In this video, we will pick up in section 7.2, talking about operations with decimals. So let's get started. We begin looking at dividing our decimals. The set of non-zero rational numbers is closed under division. That means if I divide two rational numbers, then my answer is a rational number. In our first example, we're going to look at a way to divide, but this is not necessarily the algorithm that you may have learned. This will help us build up to that algorithm. So let's look at part A. When we're dividing 128.4 by 4, we can think of 128.4 as 128 and 4 tenths. Now because I have that tenths, I can put 1284 over 10 because of the tenths decimal place. We talked about this in our last video. We're dividing by 4. Remember, when we divide fractions, our algorithm is we change the division to multiplication and we take the reciprocal of the second fraction. So 4 over 1 becomes 1 over 4. Now remember, when we're multiplying, the order that we multiply in doesn't matter. So when I multiply the fractions, we multiply the numerators and we multiply the denominators. And I'm going to think about those denominators. I can say 10 times 4 in the denominator, or I could reverse the 4 and the 10. So I could say 4 times 10 in the denominator. 1,284 divided by 4 is 321. We're multiplying by 1/10. 321 is understood to be over 1. Multiply the numerators gives us 321. And multiply the denominators, 1 times 10 is 10. We have 321 tenths, so I have a tenths decimal place. That means 1 decimal place. And so my answer is 32.1. Let's look at another example. Let's suppose we have 75.45 that we are dividing by 3. 75.45 is 75 and 45 hundredths. We have the hundredths decimal place here. As a fraction, we can write 7545 over 100 because of our hundredths decimal place. And we're dividing by 3, or 3 over 1. Our algorithm for dividing fractions says that we change division to multiplication and we flip that second fraction. That's called taking the reciprocal. When we multiply, the order that I multiply doesn't matter. So in the denominator, I can multiply 100 times 3, or I can say 3 times 100. Let's look at our first fraction, 7,545 divided by 3. I used my scratch paper, and that gave me 2,515. We're multiplying times 100. 2,515 is understood to be over 1. Multiply your numerators gives us 2,515. And multiply the denominators, 1 times 100 is 100. So we have 2,515 hundredths. Hundredths is 2 decimal places, and so my answer would be 25.15. Now, let's talk about our algorithm. When our divisor is a whole number, remember the divisor is what we divide by. The division can be handled the same as we handle division with whole numbers. The only difference is the decimal point and the quotient goes directly over the decimal point in the dividend. Let's look at how this works. I'm going to divide 4 into 128.6. Decimal point in the quotient goes directly over the decimal point in the dividend, so be sure you line up your decimal points. 4 goes into 12 3 times with none left. Bring down your 8. 4 goes into 8 2 times with none left. Bring down your 6. 4 goes into 6 1 time with 2 left. Now I want to keep dividing with my decimals until I get a remainder of 0, or sometimes you'll notice your decimals start repeating. We can write a 0 after our decimal point, and this doesn't change the value of our number. Bring down your 0. 4 goes into 25 times with none left. And so our answer is 32.15. Now let's look at part B. We're dividing 3 into 75.45. The decimal point in our quotient, the quotient is the answer when we divide, is lined up with the decimal point in the dividend. 3 goes into 7 2 times with 1 left. Bring down your 5. 3 goes into 15 5 times with none left. Bring down the 4. 3 goes into 4 1 time with 1 left. Bring down the 5. 3 goes into 15 5 times with none left. And so our answer is 25.15. Now, what happens if our divisor is not a whole number? So suppose we have something like 1.2032 and we're dividing by 0.32. So notice here, our divisor is not a whole number. What we can do is we express our division as a fraction, and we multiply the numerator and the denominator by a power of 10 so that we have a whole number in the denominator. Let's look at how this works. In part A, we have 1.2032 and we're dividing by 0.32. Now, you may have learned, as I did, if we have 2 decimal places in the divisor, then we move the decimal place over 2 places to get rid of it. And if we move the decimal place 2 places in front of the division symbol, we move the decimal place 2 places underneath the division symbol. And we line up the decimal place here. Now, here's why that works. If I write my division as a fraction, I would have 1.2032 over 0.32. In the denominator, we have 32 hundredths. So I'll multiply the denominator by 100 so that I have a whole number 32 in the denominator. If I multiply the denominator of a fraction by 100, I also have to multiply the numerator of the fraction by 100. 1.2032 times 100 is 120.32. And you'll notice this is what we have represented out to the left. We have the 32 that we're dividing by, and we're dividing into 120.32. That was after we moved those decimal places. 32 goes into 120 3 times with 24 left. Bring down your 3. 32 goes into 243 7 times with 19 left. Bring down your 2. 32 goes into 192 6 times with none left. And so our answer is 3.76. Let's look at another one. We have 14.147 divided by 0.2. I'm going to rewrite my division as a fraction. So I have 14.147 over 0.2. In the denominator, we have 0.2 or 2/10. So I'll multiply the denominator by 10, and that gives me a whole number, 2, in the denominator. If I multiply the denominator of a fraction by 10, I also have to multiply the numerator of that fraction by 10. 14.147 times 10 is 141.47. You can use your scratch paper to multiply, or notice that when I multiply by 10, the decimal place moves 1 place to the right. Now I can write my division symbol. So I have 2 into 141.47. 2 goes into 14 7 times with none left. Bring down your 1. 2 doesn't go into 1. Bring down the 4. Now don't forget to line up your decimal point. 2 goes into 14 7 times with none left. Bring down your 7. And 2 goes into 7 3 times with 1 left. If we write a 0 after the decimal place, this doesn't change the value of our number. And I bring down that 0, 2 goes into 10 5 times, and I finally have a remainder of 0. And so my final answer is 70.735. Look at example 10. The owner of a gas station must collect gasoline tax, a gasoline tax of 11 cents on each gallon of gasoline that is sold. In 1 week, the owner paid $1,595 in gasoline taxes, and the pump price that week was $3.35. Part A asks us how many gallons of gas were sold during the week. To figure out how many gallons of gas were sold, I'm going to divide the amount that the owner paid in gasoline taxes, which would be $1,595. by the amount of the gasoline tax, which was 11 cents or 0.11. And I'm going to multiply by a power of 10 so that I have a whole number in the denominator of that fraction. We have 11 hundredths in the denominator, so I'll multiply the denominator by 100. That gives me 11 in the denominator. If I multiply the denominator by 100, I also have to multiply the numerator by 100. 1,595 times 100, you can use your scratch paper, or when I multiply by 100, that moves my decimal place 2 places to the right so that I get 159,500. And now divide. 11 goes into 15 one time with 4 left. Bring down your 9. 11 goes into 49 4 times with 5 left. Bring down your 5. 11 goes into 55 5 times with none left. Bring down your 0. 11 goes into 0 0 times with none left. And bring down the next 0. 11 goes into 0 0 times with none left. So the owner sold 14,500 gallons of gasoline that week. Part B asks, what was the revenue after taxes for the week? I have 2 things I need to figure out. First, I need to know how much money total the gasoline station collected. And then second, I need to take out the taxes that were paid. Figure out how much money total the gasoline station took in. I multiply the number of gallons of gasoline, which was 14,500, by the price of the gasoline that week, which was $3.35. When you multiply here, you'll notice we have 4857500. Now I need to think about my decimal place. I have 2 decimal places in my factors, so my answer is going to have 2 decimal places as well. That means my decimal goes behind the 5. So the gas station brought in $48,575 that week. Now that includes the tax money. So my second step is I take the $48,575 and I subtract the amount that the owner paid in taxes, which was $1,595. And we get $46,980. Now, let's talk about our mental computations. We can use some of the same strategies with decimals that we use with whole numbers. For instance, breaking and bridging. So here in part A, we have 1.5 plus 3.7 plus 4.48. I want to think about breaking some of these numbers up to make my addition a little bit easier. So 3.7, I want to think about being 3 and plus 0.7. So my first step is I add 1.5 plus 3. That gives me 4.5. Then I take the 4.5 and I add the 0.7. That gives me 5.2. The last number is 4.48. Again, I want to break and bridge. So I break the number into 4 plus 0.48. So I have 5.2 plus 4, which is 9.2. And then I have 9.2 plus 0.48, which is 9.68. And so my final answer is 9.68. Now you'll notice your directions ask you to use breaking and bridging to mentally add. These 4 steps would be done in one's head. However, if you're asked to work a problem similar to this on a quiz or exam, for a show work question, this is the work that you would need to show. Now let's look at part B. First, I think about 2.3 and 6.8. 6.8, I'm going to break to 6 plus 0.8. So I have 2.3 plus 6, which is 8.3. And then 8.3 plus 0.8 is 9.1. The 7.3 I want to break into 7 plus 0.3. So I have 9.1 plus 7, which is 16.1. And then I have 16.1 plus 0.3 is 16.4. And 16.4 is my final answer. Another strategy that we used with whole numbers was using compatible numbers. So let's look at using compatible numbers with our decimals. In part A, I have 1.5 plus 3.4 plus 6.5 plus 7.6. When I think about compatible numbers with our whole numbers, we were thinking about whole numbers that added to, say, multiples of 10. Here, I want to think about decimals that add to make a whole. So if I think about 1.5 and 6.5, those are compatible numbers because the 0.5, those decimal places, a 0.5 plus 0.5, that is one whole. So I have one whole from the decimal places, and 6 plus 1 is 7, plus that whole would give me 8. So again, 1 plus 6 is 7. I have another whole from the 0.5 and the 0.5. That gives me a total of 8. 3.4 and 7.6 are also compatible numbers because my decimal places would give me a whole here. 7 plus 3 is 10, plus a whole from the decimal places, that would be 11, and 8 plus 11 is 19. Look at part B. 7.91 and 4.09 are compatible numbers because my decimal places give me a whole. 7 plus 4 is 11, plus the whole from the decimal places, that makes 12. 3.85 plus 0.15, those are compatible numbers because my decimal places here give me a whole. So I have 3 plus 0 is 3, and then a whole from my decimal places makes 4. And so that gives me 16. And final strategy that we can use with our decimals is making compatible numbers. So let's look at part A. I have 9.27 plus 3.79. Now I want to think about decimals that will make a whole. So if I think about 9.27, I can rewrite that as 9.25 plus 0.02. And 3.79, I can rewrite as 3.75 plus 0.04. I chose the 9.25 and 3.75 because my decimal places make a whole. So 3 plus 9 is 12, plus a whole from my decimal places makes 13. Add 0.02 and 0.04, that's 0.06. And 13 plus 0.06 is 13.06. Look at part B. 6.34 I can think about as 6.3 plus 0.04. And 9.73 I can think about as 9.7 and plus 0.03. I chose the 6.3 and the 9.7 because my decimal places here make a whole, so these are compatible numbers. And then I add 6 plus 9 is 15, plus the whole from the decimal place makes 16, and 0.04 plus 0.03 is 0.07. And so my final answer is 16.07. Now let's look at rounding. Now we want to round only when we don't have to know the exact numerical number. And I want to round to the nearest number. So let's suppose we have 8.7345649, and I want to round to the nearest hundredth here. Now my hundredths place is the 3, and I look at the place after that, which is the 4. 4 is less than 5, so that tells me that this long number is closer to 8.73 than it is to 8.74. And so my number is rounded down to 8.73. Again, I was rounding to the hundredths, so I look at the hundredths place, that's 3. The number to the right of that place tells me whether to leave that 3 or to go up. If the number to the right of my place is less than 5, I leave my number as it is. If the number is greater than 5, I round up. In part A, I want to round to the nearest hundredth. So my hundredths place is the 5. I look to the right of that and I have a 6. 5 or more, we round up, and so this one rounds to 7.46. Now look at part B. We have 7.456 again. but this time we want to round to the nearest tenth. The 4 is in the tens place. I look to the right of that. That number is 5 or greater, and so the 4 goes up to 5, and this number rounds to 7.5. Part C, we have the same number, but this time we're rounding to the nearest unit. The 7 is in the ones place or the units place. I look to the right of that. To the right of that is a 4. This is less than 5, and so 7.456 rounds to 7. Part D, we have 7,456, and we want to round to the nearest thousand. The 7 is in the thousands place. To the right of that is a 4, so the 7 stays the same, and this rounds to 7,000. Now look at part E. We're rounding to the nearest 10. So in the tens place is a 4. To the right of the 4 is a 5, so that tells me I go up, so this would round to 750. Finally, part F, again we're rounding to the nearest 10. The 7 is in the tens place. To the right of that is 4. This is less than 5, and so this rounds to 70. One last thing we need to talk about in section 7.2 is our round-off errors. Now, round-off errors are going to be compounded when we have computations. And when computations are done with approximate number, the final result should not be reported using more significant digits than the number that we originally had with the fewest significant digits. Here's what I mean. So let's suppose we have two numbers that we're dividing. 5.02 divided by 0.13. Now let's suppose too that we've already rounded here. I rounded 5.02 and I rounded to get the 0.13. When we divide 5.02 by 0.13, we get 38.61538462 and so on. Now, because we have two decimal places in our original numbers, we might be tempted to round this to two decimal places and write 68.62 for our answer. However, we want to think about significant digits in the original problem and the least number of significant digits. 5.02 has three significant digits, a 5, a 0, and a 2. 0.13 has two significant digits. That 0 before the decimal place is not considered significant. So my final answer should have only two significant digits. That was the least number of significant digits. That means my final answer should have two digits, and so this would round to 39. So what does this mean? The bottom line is it doesn't make sense for our answer to be more precise than the numbers used to calculate it.